Hello, my dear students. Today we have the third lecture of the chapter Some Basic Concepts of Chemistry, 11th standard. And this particular is a section based on laws of chemical combinations. As per your current JEE and NEET syllabus, this is the first point of your syllabus. And lecture number 1 and 2, what we did earlier, that was considered as a very fundamental thing. On this particular section, in prior years, very few questions have appeared, but the questions have been very simple, very scoring. So if you do this topic, do this section in a great detail, there is a great chance that you might score very good in this particular section. Let us begin our study of different laws of chemical combination. And the first law which we are going to study right now is called law of conservation of mass, stated by Lavoisier in 1744. For exams, usually they never ask you any names of scientists as such. So this is only for your information. Let us understand what is this law and what is the statement of it. So stating the law as he had given, it states that matter can neither be created nor destroyed. This particular law is applicable only to chemical changes, only to physical changes, but not definitely to nuclear reactions. Because in nuclear reactions, there is a large amount of mass and energy conversions. Let us understand this with an example. Suppose you consider this reaction of sodium chloride with silver nitrate, AgNO3 with NaCl. Now, when you are reacting this, you can clearly understand Cl combines with Ag to form AgCl. Na combines with NO3 to form NaNO3. So, according to this particular law of conservation of mass, total mass of NaCl and AgNO3 before the reaction must be equal to the mass of NaNO3 and AgCl after the reaction. If I state it in a generalized way, I can say total mass of the reactant before the reaction, total mass of the product after the reaction are always equal. When you are going to solve numerical problems on this, you just need to keep this last formula in mind. Let us try doing some questions on this. Very simple ones in the beginning. First, if 28 gram of nitrogen is combining with 6 gram of hydrogen, you know how much of ammonia is present initially. When we say initially, that means reaction has not started. That is why this is going to be 0 gram. So please remember, if someone asks you about initial amount of product in the initial state, it's always going to be 0. So now finally, if they have said that nitrogen and hydrogen have completely reacted, so you can see here 0 gram and 0 gram are left. So how much ammonia is produced here? 28 plus 6, that's going to be 34 gram. For the simple reason, total mass of reactant before is equal to the total mass of product. Let us understand this with another example. Now check here, they have given us calcium carbonate producing calcium oxide and carbon dioxide. Now over here, let us introduce the concept called molecular weight, also known as molecular mass. So if you want to find molecular mass of calcium carbonate, you must know their atomic masses. In next video, lecture number 4, we will be doing this concept in detail, but currently let us revise it. So calcium's mass is 40 gram, carbon mass is 12 gram, and oxygen individually is 16. There are 3 atoms. So if you find the total of this is going to be 40 plus 12 plus 48. So the total comes out to be 100 gram. Similarly, calcium oxide molecular weight, if you see, it's calcium's weight plus oxygen weight, that is 56 gram. And similarly, molecular weight of carbon dioxide come as 12 plus 32, that's 44 gram. The question is why I did all this calculation. Check the number given over here. They have said initial mass of calcium carbonate is 50 gram. You know, molecular mass is 100. This is taken exactly half of it. So if I would have taken 100 gram of calcium carbonate, masses of calcium oxide and carbon dioxide would have been 56 and 44. But since I have taken 50 gram, everything is going to be half of this. So the mass of calcium oxide will be 28 gram, mass of carbon dioxide will be 22 gram. I hope this calculation is understood. Example 1, we did a case where the molecular masses were equal to the taken masses. In example number 2, we have taken a case where molecular masses are half of them. So product molecular masses are taken half. Let us do another kind of case wherein I've deliberately kept the same molecular masses again. So this is molecular mass 100 gram. This is 56 gram. This is 44 gram. So you can see initially 100 gram is taken. So how much is expected over here? You are supposed to get 56 gram and 44 gram. But if you see how much is leftover mass here, this is the mass leftover. So I hope you can understand how much is used up. The used up mass is only 50 gram. So if only 50% quantity is used, then produced masses will be also 50%. So your answer of the product masses is going to be 28 gram of calcium oxide, 22 gram of carbon dioxide. This is a case, example 3, where the mass 100% is not reacting. Only a certain quantity reacts. So accordingly, we find the mass of the product. This is a very tricky situation. I hope everyone follows it. Let us solve some numerical problems based on this information. Once again, like all our lectures, all of you read the question once, pause the video for a moment, think over it, and then we'll see the solution. So what is given to us? Silver nitrate will react with 5.85 gram of sodium chloride. So our reaction which is there is going to be reaction of silver nitrate with sodium chloride. This is going to produce silver chloride and sodium nitrate. So read the data given to us. We can use the law as mass of silver nitrate will combine with mass of NaCl, producing mass of silver chloride plus mass of NaNO3. I have used simply law of conservation of mass. What mass of silver nitrate? That means this is to be calculated. Will react with 5.85 gram of sodium chloride. So here comes 5.85 to produce 14.35 gram of silver chloride. 14.35 gram and 8.5 gram of silver nitrate. This is going to be very simple. So mass of silver nitrate will be 14.35 plus 8.5 minus 5.85. So if you do all this calculation, you will get the answer as 17 gram. We are simply using law of conservation of mass. In any question, if you see a question based on reaction and its masses. Remember, you are going to use law of conservation of mass. Let us go ahead, take another question similar to this and check what reaction is given to us. 6.3 gram of NaHCO3 is added to 15 gram acetic acid. So let us try the equation first. This is CH3COOH, a carboxylic acid treated with NaHCO3. So what it will produce? It will produce CH3COONA, that is CH3COO from here, Na from here, with H2O and CO2 as byproducts. So check the question. 6.3 gram of NaHCO3 taken, 15 gram acetic acid taken, residue was 18 gram. Now over here, what do we mean by residue? Whatever remains as solid or liquid, it's taken as residue. What mass of carbon dioxide is released? So I hope now you can understand this. Mass of acetic acid plus mass of NaHCO3 giving this 18 plus mass of carbon dioxide. So X will be equal to 15 plus 6.3 minus 18. So this calculation should give you the final answer as around 3.3 gram of carbon dioxide. You know, this is a question type where they have not given us individual masses of the products. They have differentiated it between a gaseous substance than the other mixture of products. This is just another variety of giving the problem. Let us come back to now the laws originally. So after completing the first law of conservation of mass, we come to a second law called law of definite proportions. This law was suggested by a scientist, Joseph Proust, in 1799. And see what is the statement the law says. A given compound contains always exactly the same proportion by weight, irrespective of the source. Given compound always contains same elements combined together in the same proportion by mass. There are some typing corrections in the words. This is together. Now, to understand the statement better, let us take the example. I've just written the statement here for reference. Joseph Proust performed an experiment with a compound called copper carbonate. He had two kinds of samples with him. One sample was a natural source, and second one was made in laboratory. He analyzed both these samples for the content of copper, carbon, and oxygen. So he found that whichever might be the source, the percent of copper, oxygen, and carbon was always used to be exactly same. Now you can see the statement once again. A given compound always contain exactly the same proportion by weight, irrespective of the source. That compound will contain same elements by proportion of mass. Now, some of you might wonder how this percentages is found. So we'll just take a detour to understand how to find the percentage. We consider, suppose, molecule of H2O. So how do we find percent of hydrogen in it? You know, the formula is mass of that element divided by the molecular mass multiplied by 100. So in H2O, you can understand the mass of hydrogen is 2. Molecular mass of water is 18. Multiply by 100. So percent of hydrogen is calculated as 11.11. Suppose if someone asks you to find percent of oxygen, since there are only two elements, subtract this from 100 and we will get an answer 88.89% of oxygen. So in case in any numerical problem, you are asked to find some percentages. This is the method we are going to follow. Let us come back to the law once again. If you take a different example, let us say water. Water will always contain the same percent as 2:16 or 1:8. Now, here this mass, what we are seeing is not percent wise actually. You know, the real percentage was what we saw earlier, 11.11 and 88, which also comes down to the same thing. So if I take real percentages, it's 11.11 is to 88.89, which roughly comes out to be 1:8. So rather than every time taking this kind of complicated calculations, we can simply take atomic and molecular masses. Let me show you with a different example. In carbon dioxide, carbon's atomic mass is 12. Oxygen's atomic mass is 16. So ratio by mass will be 12 carbon. Since there are 2 oxygen, 16 into 2, 32. Divide throughout by 4. If you simplify this by 4, your ratio is going to be 3:8. So the simplified law once again to understand is, after all these calculations, if a compound is given, if different sources are given, it's always going to contain same percentages of elements. The ratio always will remain same. Let us solve a numerical problem on this. Read it once before we go ahead. Case number 1 is first experiment given. 1.80 gram of a metal burnt in oxygen gives 3 gram of oxide. So what I understand from case number 1 is, you know, mass of metal they have given us as 1.80 gram. What will be mass of oxygen over here? If you understand, this is mass of oxide, that minus 1.80 will give you the mass of oxygen, because oxide is made up of metal and oxygen. So if I find a ratio of metal is to oxygen, it will be 1.80 is to 1.20. Divide it throughout by the smallest number 1.20. You will get an answer 1.5 is to 1. We have done a calculation for first case. Let us analyze the second case now. 1.50 gram of the same metal. So once again, mass of metal will be equal to 1.50. In some other manner, how that is done, we are not interested. 2.50 gram of oxide. So once again, I can find mass of oxygen. And how much that will be? 2.50 minus 1.50. That's equal to 1 gram. So ratio of metal is to oxygen will be 1.50 is to 1. Now, if you see this ratio in case number 2 and this ratio in case number 1, they are absolutely identical, which proves law of constant proportion is correct. So after performing this, let us take up some more questions about this. This was a question asked in 2025 MHT CET exam. Understand the thing. 2 gram of a metal burnt in oxygen forms 3.2 gram of oxide. So if you can understand the kind of calculations we did earlier, and if you apply them right away, my case number 1 is metal amount 2 gram, What will be the oxygen amount now? 3.2 minus 2 gram. So metal oxygen ratio is coming out to be 2:1.2. So if I divide by 2 and 1.2, it comes out to be 1.67:1. So this was my case number 1. Let us quickly go for case number 2 and find out the similar calculations. 1.42 gram of metal forms 2.27 gram oxide. So we can subtract this two things and get this amount as 0.85 gram. So this is going to be 1.42 is to 0.85. If I divide entire number by 0.85, I get the answer 1.67:1. So since both the ratios are similar, this talks about law of definite proportion. The way we had taken the question, you can see very similar question came in the exam of MHT CET. After finishing the first two laws, let us go to a third one proposed by a very famous scientist, Dalton, known as law of multiple proportion. This particular law needs a little wider thinking. Let us understand the statement, then as usual, we will take example. If two elements can combine to form more than one compound, the mass of one element that combines with the fixed mass of the other one will be in a ratio of small whole numbers. Once again, unless we see the example, you may not understand. We are taking here 2-3 examples properly to understand the statement. Example number 1. We are taking here two different elements. That is, one is hydrogen and second is oxygen. The compounds considered are H2O water and H2O2 hydrogen peroxide. If you see both these molecules, amount of hydrogen in both of them is similar. That is what the statement says here, fixed mass of the other element. So out of the two elements, we have made hydrogen amount as fixed. Don't look at it right now. Check the amount of oxygen. Here we have one oxygen, that's 16 gram. Here we have two oxygen atoms, that's 32 gram. These amount of oxygen will create a simple ratio of 1:2. So if two elements combine, so let us see the statement in terms of this example. If two elements can combine, that is hydrogen and oxygen, to form more than one compound, H2O and H2O2, masses of one element, that's oxygen in this case, which is 16:32, which combines with the fixed mass of other element being hydrogen, are in the ratio of small whole numbers, that is 1:2. So the case here is how to identify this particular law. You will have two elements, you will have their two compounds. One element will be in a same amount, like H2, H2. So you will see hydrogen amount is same, oxygen amount changes. Let us take one more example to understand this. So in this case, carbon monoxide and carbon dioxide is taken. Carbon amount you can see is fixed in both the cases as 12 gram. And once again, oxygen is in a ratio of 16:32. That means 1:2. So the case is again same. Fixed element is carbon. Fixed mass is 12. Ratio of oxygen's mass is taken. That is 1:2. Now the third example, which we'll be seeing here, is a little bit different one. We are considering two elements here, that's nitrogen and oxygen. But there is some difference here. There are 5 compounds of nitrogen and oxygen taken: N2O, NO, N2O3, N2O4, and N2O5. In first, third, fourth, and fifth, you can see amount of nitrogen everywhere is same, 28 gram. Find the amount of oxygen accordingly. 1 oxygen atom, 3 oxygen atoms, 4 and 5. But the difference comes over here. Here there is only one nitrogen atom whose mass is 14. By the way, nitrogen's atomic mass is 14, oxygen's is 16. To make up this amount equal like other thing, we have multiplied this nitrogen amount. Now, if you have multiplied nitrogen by 2, obviously oxygen amount also is multiplied, and that amount now becomes 32. So now if you put all these masses in ratio of mass, it's 16, 32, 48, 64, and 80 gram, which is, by the way, the table of 16. 1:2:3:4:5. This example teaches you one important concept, that if in case they ask you an example where the atoms are not matching, you can multiply, make them equal, and then use it. We will have a kind of similar question on this in the forthcoming problems. So this is a question of MHT CET 2024. Which of the following pair of compounds does not demonstrate law of multiple proportion? What is the condition of multiple proportion? If I summarize again, 2 elements, there 2 compounds. So let us compare. Copper, oxygen, copper, oxygen. This is good. Sodium, nitrogen, oxygen. Now comes the trouble. We have 3 elements over here. Calcium, carbon, oxygen. 3 elements. Plus, one is sodium, another is calcium. This definitely cannot meet the condition of multiple proportion. This is our answer. Just for the sake of checking, check the other ones. Carbon, oxygen, carbon, oxygen. Nitrogen, oxygen, nitrogen, oxygen. So all are going to fall in multiple proportion cases. Only this is not going to be allowed. So answer is B. Check another question of CET 2024 again. What is the ratio of mass of nitrogen that combines with 16 part of weight of these particular compounds? So a bit of calculation. N2O, NO, NO2. What is the mass of nitrogen here? 28 gram, 14 gram, 14 gram. What is the mass of oxygen here? 16 gram, 16 gram, 32 gram. So what is the question asked? The mass of nitrogen which combines with 16 parts by weight of oxygen. So over here, this is going to be 28. The second one is 14. But since this part is 32, I need to divide by 2 to make it 16. I will divide it by 2 to make it 7. So this will be 7. So if I divide this throughout by 7, it will be 1 here, 2 here, 4 here. So the ratio comes out to be 4:2:1. You can see MHT CET has asked a bit different type of question over here, which needs calculation, but the example is same as our syllabus we had done. We will now take up 4th law known as reciprocal proportion, given by a scientist Richter. This law is not a part of Maharashtra syllabus. This is not given in NCERT, but most of the JEE, NEET and CET books give you this law as an additional one. Let us understand this statement of this law. When 2 elements combine separately with a third element, form different types of molecules, their combining ratio is directly reciprocated if they form directly, if they combine directly. Once again, a complicated statement. Let us take this with an example. Consider we have three elements here, that is carbon, hydrogen, and oxygen. When they are combining, this is the way they may form. Carbon with hydrogen forms methane. Carbon with oxygen forms CO2. And hydrogen with oxygen forms H2O. You know what are their masses here? If you take methane, carbon 12, hydrogen 4, so that is going to be 3:1. Carbon, oxygen, carbon 12, oxygen 16, 3:4. So in this calculation, you can see amount of carbon is fixed. Amount of carbon is fixed, that's 3 and 3. They say, check the ratio of the remaining one, that is water. So if water is combining with it, how the things will be? Water is going to combine this way. So hydrogen 2, oxygen 16. This ratio will be in form of 1:8. So you can see the ratio they have taken. 12 gram of carbon combines with hydrogen. Ratio is 3:1. Oh, I'm sorry, I did a mistake in calculation over here. I will just rectify it. This amount of oxygen taken is 32. So that is 3:8. That's why the ratio is 1:8. So in carbon dioxide, it's 3:8. Keeping the amount of carbon in both of them similar, the ratio 1:8 can be seen over here. So when three elements are combined, one of the element amount is kept fixed. That is the top element. Whichever ratio it is forming with the base elements, hydrogen, oxygen, same ratio is shown in that element compound, that is water. This law is known as reciprocal proportion. There are no questions as such in the syllabus asked because it's not a part of NCERT. We come to another law, and this law, trust me, is going to be very important and useful for you even in the 12th standard syllabus. It's called Gay-Lussac's law of combining volume. The statement is much easier. When gases combine or they are produced in a reaction, they do so in a simple ratio by volume, provided all the gases measurement is done at the same temperature and pressure. Comparatively easy statement. So suppose we take a reaction of hydrogen and chlorine together, it forms 2HCl. So how much amount of hydrogen is taken here? 1 volume. Chlorine taken is 1 volume. HCl is 2. So the ratio as per this Gay-Lussac's law is hydrogen is to chlorine is to HCl as 1:1:2. They form a simple ratio by volume, provided all the measurements are done at same temperature and pressure. Let us take up some numerical problems on this. Read up the first problem and then we can solve it. So if you read the question, they say 100 meter cube of hydrogen is allowed to react with 150 meter cube of chlorine. Calculate the volumes of product, unreacted volume of gas, and so on. So first job is to let us write the equation. Hydrogen gas is combining with chlorine gas to produce 2HCl. A very important thing over here is you must have a proper balanced equation, without which we cannot solve the problem. How much are the volume given in the equation? 1 volume, 1 volume, and 2 volume. How much they have given us? 100 meter cube of hydrogen, 150 meter cube of chlorine. You know, whenever in a problem, you can see two different volumes. We have to consider standard unit volume as the lowest number. So among 100 and 150, 100 is the small number. I take that as a standard one. Okay, substitute this 100 or one volume in all the cases. So it comes out to be 100 meter cube hydrogen is going to combine with 100 meter cube chlorine to form 2 into 100, that's 200 meter cube HCl. So basically, volume of HCl which we are going to get will be 200 meter cube. Now, if you observe carefully, we had taken 150 meter cube of chlorine. So, volume of unreacted chlorine will be 150 taken, 100 only used. So, 50 meter cube is left over. So, we have got two things which we have asked and calculated. Volume of the gaseous product, matlab HCl, and unreacted volume of the gas, that was chlorine. Whoever is studying through these videos or revising through these videos, you must always, after finishing looking at each point, must stop the video and write down, practice the problem on your own. Watching video multiple times won't help you. Only solving on your own is going to help you. Please remember that. Let us do a little different level of problem of Gay-Lussac. Calculate the volume of air at STP, standard temperature and pressure, which contains 19% oxygen by volume, required for the complete combustion of 0.5 dm cube of hydrogen sulfide. Now, the first thing, as we said, is a balanced equation. We have been given hydrogen sulfide gas. Combustion means reaction with oxygen. And this will produce two things. One is H2O and second is sulfur dioxide. First, let us balance the equation. How do we balance it? Count the important elements, primary element of left-hand side, balance on the right-hand side. So, balance hydrogen first from left to right, balance sulfur from left to right, then balance oxygen from right to left. So, hydrogen H2 balanced, one sulfur balanced. Now I have 1 and 2, that is totally 3 oxygen atoms. So this is balanced as 3 by 2. Now those who are seeing this kind of balancing for the first time, let me explain. 3 by 2 multiplied by atoms of oxygen. So this comes out to be 3 atoms of oxygen, which we balance here. So this is how a fractional balancing is done in exams. So how much volumes do we have? Here we have one volume. Here we have 3 by 2 volume, one volume and one volume. They have said 0.5 decimeter cube of H2S. So 0.5 decimeter cube of H2S is going to react with how much? 3 by 2 into 0.5 decimeter cube of oxygen. Right? This is going to be the decimeter cube of oxygen produced. I will not calculate this right now. We will just remember this currently. This much amount of oxygen is required. So I will say required amount of oxygen. Now come to the second part of the problem, which is a tricky one. They are not doing the reaction with oxygen. They are doing the reaction with air. And air contains 19% oxygen only. So what I know is, if I take 100 decimeter cube of air, it contains only 19 decimeter cube of oxygen. How much oxygen do I need actually? 3 by 2 into 0.5 decimeter cube I need. So for getting such amount of oxygen, how much decimeter cube of air I must have taken? So now if you cross multiply this is going to be 3/2 into 0.5 into 100 divided by this number 19. This answer after calculation comes out to be 3.947 decimeter cube of air. This is the amount of air we need to have so that we get sufficient oxygen out of it. If you are practicing this question, you must read this, practice it once again. This is a bit of a tricky question. Let us go ahead and do another type of question similar to combustion. What is the weight of oxygen required for complete combustion of 2.8 gram ethane? If you know your organic chemistry, ethane is C2H6 and the molecular weight is going to be 12 into 2 plus 1 into 6. That's going to be, just cancel this number. So compound given here is ethane, so this is going to be 30 gram. So let us calculate now the reaction. C2H6 is reacting with oxygen to produce carbon dioxide and H2O. Like in earlier case, let us balance this now. 2 carbon is balanced here, multiplied by 2. For 6 hydrogen is 3 into 6, 2. So oxygen is going to be 4 and 3, 7. So this is going to be 7/2. Now there is a little difference here. The question is about weight, not volume. So here, molecular weight of ethane is 30 gram. 7/2 into 32 gram is the amount of oxygen. So it means if 30 gram ethane is taken, we need 7/2 into 32. That is 7 into 16 gram of oxygen. I hope my relation in the numbers is understood by everyone. 30 gram of ethane combining with 7/2 into 32 gram. This comes out to be, I think, 112 gram. So how much they are giving us? 28 gram ethane if given. How much amount of oxygen is required? So 28 into 112 upon 30. So 112 into 28 divided by 30, which comes out to be around 104.53 gram oxygen is needed. Now, there is a small difference over here, which I will demonstrate you not by changing the problem. You can see they have said 2.8 kilogram. So I did my calculation with respect to gram. We can simply make this as kilogram, 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 and even this as kilogram. So if a gram question is asked in kilogram, if everything is changing, you just change the unit. You don't have to multiply, divide by anything. Let us take one more problem of this type. And this was question asked in NEET 2008 examination. Read it before we go ahead. So the question asked is about, once again, combustion of propane gas. So propane is C3H8. Once again, combining with oxygen, and that will produce CO2 and H2O. So let us balance 3 carbon, 3 carbon, 8 hydrogen, 4 2s are 8 hydrogen. Count oxygen on product side, 6 and 4, 10. So that's 5. So what are the volumes, standard volume we can see in the equation? 1 volume, 5 volume, 3 volume, and 4 volume. Come to the question. They want to burn 1 liter of propane. So if it is 1 liter of propane, we will need 5 liter of oxygen for the reaction. Let us see the options given to us, and you can see the answer is very, very simple. I hope how the balancing is done is very clear. I repeat the rule again. Whenever you are doing balancing of a combustion reaction, check carbon on LHS, balance on right hand side. Count hydrogen on LHS, balance on right hand side. Oxygen, count on RHS, balance on the left hand side. By this trick, you can balance each and every reaction. Let us take up one more question of this pattern because this question is quite popular in exams. 20 ml ethane is completely combusted to form the volume. So let us once again do the reaction in the same manner. C2H6 burnt with oxygen to form CO2 and H2. Carbon 2 times, carbon 2 times. Hydrogen 6 times, 3 2s are 6. This is 4 oxygen and 3 oxygen, 7. So this is 7 by 2. So 1 volume, 7 by 2 volume to form 2 volume, 3 volume. Read the question again. 20 ml ethane. So this is taken as 20 ml. How much of volume of carbon dioxide is produced? So if 1 volume is producing 2 volume, let me mark. If 1 volume of ethane is producing 2 volume, naturally 20 ml will produce how much of carbon dioxide? So simple mathematics that will give you 40 ml. I hope Gay-Lussac's law, we have taken a large number of sums because you have been getting questions on this in most of the examinations. Let us go ahead with the things. Gay-Lussac's law, it's so important that even with very recent examinations, the questions have been coming. Let us come to the next law, which is called Avogadro's law. A very easy law that way, and very easy questions also have been appearing on this. The law statement is very simple. It says equal volumes of all gases at the same temperature of pressure should contain equal number of molecules. If you take different kind of gases like maybe hydrogen gas, carbon dioxide gas, sulfur trioxide, and even monoatomic gas like argon, as long as the measurement is done at same temperature and pressure, the equal volume will contain same number of molecules. What does it mean? Suppose I'm taking hydrogen and let us say carbon dioxide. Temperature and pressure are maintained same. And suppose both are taken as 1 liter. Both of them will contain exactly same number of molecules. So these are molecules of hydrogen. These are molecules of carbon dioxide. Let us assume that I change the volume to, let us say, 2 liter. You will also see the number of molecules have been changing. So as we keep on changing the the volume, amount taken is also going to change. So molecules will also change. So this particular thing was later on connected to the mole concept. We have not done mole concept yet. We'll be doing this after around 2 lectures. So the statement says that volume of gas will be directly proportional to the number of moles taken at STP. We have been talking about the term STP again and again. So let us talk about this. What is this STP? It's standard temperature and pressure. There have been two conventions in use. One is an old convention where temperature is 0 degrees Celsius, of course, matlab 273 Kelvin. Pressure taken is 1 atmosphere. In such condition, the standard volume of a gas you get is 22.4 liter. Liter is same as decimeter cube. There have been a new modern convention for STP, wherein minor change is done from 1 atm to a pressure of 1 bar. And because of this, by change of calculation, now the new volume is 22.7 liter. If you are doing any calculation to that minute extent of using this 1 bar and 1 atm, your answers will slightly be different. But for most of the practical cases, they are taken equal. Let us do a numerical problem which connects Gay-Lussac's law with Avogadro's law. The last two laws what we studied. And this was a question asked in NEET 2026 exam. Read it once again. 1 decimeter cube of carbon dioxide passed over coke. So what kind of reaction do we have? Carbon dioxide gas reacting with carbon solid. Heating is necessary. Volume of the product produced, which is going to be carbon dioxide. And if you balance the equation, this is 2 times. So if I consider the initial condition of the reaction, this is 1 liter. Being solid, volume is not measured. And this is 0 liter. So, after the reaction, what you will get? From here, 2x molecules are produced, suppose. So this will be 1 minus 2x. This is after the reaction has taken place. So now let us calculate the total final volume. And how much is that? 1 minus x. Oh, I'm sorry, this is not 2x. This is going to be x because it's only one molecule used here. So 1 minus x of carbon dioxide plus 2x. And this amount they have said is 1.4 decimeter cube. So go ahead, calculate with this. So this is going to be 1 minus x equal to 1.4. So x is going to be 0.4 decimeter cube. So if I substitute this now, volume of carbon monoxide is going to be 2 into 0.4. That's 0.8. Volume of carbon dioxide leftover will be 1 minus x, that is 0.6 dm cube, right? So if you see the options of it, they might overlap, over here. So they are going to be 0.6 decimeter cube of CO2 and 0.8 decimeter cube of carbon dioxide, that is over here. So we are going to use here the both formulae, that is Avogadro's law as well as Gay-Lussac's law. We will come back to the last part of the topic here, that is Dalton's atomic theory. This was proposed as the first theory of atoms or structure of atom, you can say, by John Dalton. And there are some postulates given for the theory. Let us understand them. We will criticize the theory after this. Matter consists of indivisible atoms. For the first time, Dalton suggested that matter is made up of atoms. All the atoms of a given element have identical properties like identical mass. Of a given element, all of them will have identical mass. Atoms of different elements will have different mass. Compounds are formed when atoms of different elements combine in a fixed ratio. Chemical reactions involve merely reorganization of atoms. Atoms are neither created nor destroyed. Let us analyze all the points after we have just read it once. First, atoms consist of indivisible atoms. Matter consists of indivisible atoms. Today we know that atoms are no more indivisible. You can break down the atom, create atomic energy out of it. So in today's context, matter consists of atoms is fine. Indivisible, we cannot say. But of course, Dalton had given it, so we just follow it. Atoms of given element have identical mass. So if you consider hydrogen, every atom of hydrogen is going to have a mass of 1 gram. But this has a flaw. If you consider isotopes, the statement will not be correct. In Dalton's time, isotopes were not known. That's why he could make the statement. Compounds are formed when atoms of different element combine in fixed ratio. This sounds quite similar to the law of definite proportion, which we heard in today's class. So if you take one single compound, ratio is similar. That's what the law says. Reactions involve reorganization of atoms, neither created nor destroyed. This is nothing but law of conservation of mass, which we heard very first today in the class. So basically the law is in support to different laws of chemical combination. You can call this as importance of the theory. Limitations is the law does not talk anything about gaseous volume. That means Gay-Lussac's law was not covered in his time. He gave importance to masses rather than volume. He could not explain why atoms combine to form molecule. Basically, about the terms like chemical bonding and such thing, the law was not that good. Of course, not his fault, because in 1808, all these things were not discovered in science. The theory is very small, but on this currently, JEE and NEET people have been asking questions. This is NEET 2025 question. Read it and you can see what answer it could be. Dalton's atomic theory could not explain which of the following: law of multiple proportion, law of gaseous volume, conservation of mass, definite proportion. Law number A is about mass, conservation is about mass, proportion is about mass. Dalton's theory talks more about masses, never about volume. So the answer for this would be law of gaseous volume. This is a question which was asked in JEE 2020. Usually a bigger question was asked at that time. So let us analyze and see what the answer could be. So analyze it. Amongst the following, which was not proposed by Dalton: all atoms of given element have identical properties, including identical mass. Atoms of different elements have different mass. This is, of course, a true statement, as we know. So this is definitely not an answer. Matter consists of indivisible atoms. This is also true. Remember, they are asking not proposed. When gases combine or reproduced in gaseous chemical reaction, they do so in a simple ratio by volume, provided at the same temperature and pressure. Remember, Dalton doesn't talk about volume at all. So this must be the answer, but just reconfirm it with this statement. Chemical reactions involve reorganization. They are neither created nor destroyed. This is true. So basically, both the questions were asked in the same manner, but by giving different statements. So today's lecture, we have covered the different laws of chemical combination, and which was 1.5 of your NCERT, and Dalton's theory of atom, which was 1.6. In the next class, we will be seeing atomic mass, molecular mass, and slowly go to the mole concept. Thank you so much.